Let's take a look at using an array in conjunction with a sorting algorithm. So one common thing that you'll want to do when working with an array is rearrange the elements such that there's an ordering. And in the case of integers, it could be ascending or descending, so from lowest to highest versus highest to lowest, and so forth. So we won't be getting into algorithms too much in this class, but essentially an algorithm is just a fancy word for saying a series of steps to solve a problem. So in our case, the problem is we have an array and we're populating it with random values, so it's most likely not going to be sorted. So we want to fix that and make sure that it's guaranteed to be sorted. So there's lots of different algorithms we can use to sort, but we'll be using bubble sort because it's probably the simplest to implement. Now, bubble sort actually isn't a very good sorting algorithm because as the length of your array increases, the amount of time it will take to sort that array increases exponentially. So it's not very efficient with larger arrays, but it's easy to write, so we'll use that one. So to implement bubble sort, we'll use nested for loops. And what bubble sort says is if we iterate through our array n squared times, where n is the length, and swap elements where appropriate, then by the time we're done, it's guaranteed to be sorted. So I already have the code here to iterate through the array n squared times. But now we need logic to swap two elements if needed. So swapping two elements is actually a little more complicated than you would think, because if you could imagine having two variables a and b, well, if you wanted to swap those, you couldn't just move a to b and then b to a, or vice versa, because the second you move a's value into b, then when you would try to move b back into a, you wouldn't be able to remember what used to be in b because you just overwrote that data with a. So to swap two variables, we need to introduce a third variable to act as temporary storage. So the first variable that gets overwritten can be remembered, essentially, and then put in the second variable. So we can do that by saying int temp, and I'll actually assign temp as myArray sub j, and then we want to compare that with and swap with the neighbor to j. So now that we've saved myArray sub j, we can put a value there. So then we can say myArray sub j is equal to myArray sub j plus 1. And then after we made that swap, we can say myArray sub j plus 1 is equal to what used to be in myArray sub j. So it's just 3 lines, but we can't forget that temporary storage. But one thing we need to do is make sure we only swap elements if it makes sense. So if we want to sort it to be ascending, we only swap elements if the element with the lower index has a higher value than its neighbor that has a higher index. So we can check that with an if statement saying if myArray sub j is greater than myArray sub j plus 1, then we swap, but only then. And we're actually going to have to change the condition in our inner loop here to myArray.length minus 1, because if you notice, when we iterate through this loop, we're accessing the next index. So If we went all the way to the end and tried to access j plus 1, we would get the index out of bounds error or exception, and our program would crash. So after running through this, we should have a sorted array. Let me go ahead and print the array again to make sure. And let's give that a try. Yeah, so we almost ended up with a sorted array the first time. But you can see it is now sorted. So yeah, no matter what gets generated for the first one, as long as we iterate through the array n squared times and swap when needed, we're guaranteed to end with a sorted array. And let's say we wanted to sort it to be descending instead of ascending. Well, all we have to do is flip this little comparison operator so that we'll swap in different situations. So now it's highest to lowest. So if I set a breakpoint here and move the printing logic inside, we should be able to watch the list resort itself as it goes. And let me add a print line there. So if I run that in debug mode, we have our initial array, and every time I continue our program, we should be able to watch it sort. So yeah, let me move the breakpoint. Okay. Alright, so yeah, every time our array prints, you should see some swapping going on. And it's already sorted. So let's change that back to sorting it in an ascending order. So yeah, and it's called bubble sort because the values will sort of just bubble up as you swap until they're in the correct position. And yeah, so we can make our array larger if we want, and we should still get the same results. So yeah, it's quite a bit bigger now, but you can see the result array is sorted appropriately.